So today we're going to be demoing VisualCAD CAM, our latest version, which was just released earlier last week. It's called VisualCAD CAM 2021. So I'm going to go ahead and select the shortcut on my desktop. And this will start up VisualCAD CAM 2021. As you can see, the splash screen showing up and the VisualCAD CAM 2021 is loaded. VisualCAD CAM uses what is called a plugin architecture, where it runs inside of our VisualCAD framework, and VisualCAD framework offers you, tools for importing files from a variety of different file types or translators. We have a wide range of file types in here, as you can see. You can basically go ahead and choose the file type that you like to bring in, and you can bring in, different file formats like step, IGES, parasolids, DXF, DWG. We can also work in mesh geometries like STLs, OBJs, and a whole wide range of file formats. It also offers you tools for viewing, displaying. You can also create curves, which are like sketches for 2D modeling. You can turn them into solids or surfaces by extruding them. We also have mesh modeling, dimensioning, and analysis tools. Now, all of these tools that you're seeing here are the purpose to facilitate, make it easier for you in terms of machining. So these are not intended to replace your mainstream CAD system that you could be using for your design work. So I'm going to go ahead and load the file that you had shared with us. I just did a simple drag and drop in here, and you can see that from the file explorer, I just did a drag and drop, and then the file is loaded into VisualCAD. Okay. Now, as the file is loaded, you can see that the part appears in a shaded, it looks like a poly surface what you have, right?
Perfect, yeah.
Okay. You can view the part in multiple viewport layouts. You can right click and say quad viewport. It shows a view from the top, from the perspective view. You can turn on or turn off the grid display, and you can view it from different views. Now, over on the left side here, what you're looking at is called your milling browser, which is part of VisualCAM. So VisualCAM appears as a plugin in VisualCAD. So it works as a plugin architecture. So we have different modules. We have milling, turning, profile nesting, G-code editor, mesh, nest, art. So we have several different modules in here. And today our demo will be focused on the milling module. Our milling module is offered in different levels or configurations, starting with Express. We have standard, expert, professional, and premium configuration. So depending on your needs for programming, the number of axes you have on your CNC machine tool, and the type of tool paths and you're looking to generate, we would be able to recommend the appropriate configuration for your needs.
Okay, looking onto the standard or the expert version, a little bit discussing with myself at the moment, because I've got a 4-axis, but I normally just use it for turning the workpiece, and I'm not doing a 4-axis milling on it. I'm just doing indexed machining.
Okay. So you can do both indexed and continuous machining, starting with our expert configuration. The standard offers 2- and 3-axis milling capabilities. So the machining browser that you're looking at over here on the left side has 2 main tabs, program and simulate, and you have a ribbon bar under each tab. So the workflow is you work your way from left to right as you work through each of these groups in here. And the simulate tab allows you to run a cut material simulation or verification. Now, right below the machining browser, we have what is called a machining objects browser, which allows you to either create tools, or you can even bring in a library of tools. As you can see, I have a library of tools loaded, and VisualCAM will continue to load the last loaded tool library on each project you're working on. So we support different tool types, starting with ball mill, flat mill, corner radius tools for engraving, chamfer, taper, thread mill, face mill. We have dovetail tools, fillet milling tools, lollipop cutters, form tools, or user-defined tools where you can model the tools. And then, of course, you have tools for drill, center drill, reamer, tap, bore, and reverse bore. And we also have. Is it
possible to load a tool table from the machine?
You would have to convert it to the format of our, if you're using a CSV format, you have to convert that to our CSV format, so you can create a bunch of tools in here. And when you save tools to a library, we have 2 formats. We have
Okay.
our proprietary format, which is called knowledge-based file format, which is VKB, or you can save it as two library file formats, which is CSV. So you can use our table format in CSV and you can bring it in. So you can export it as a CSV, and then when you open it in a spreadsheet application, you can view the table format and you will have to convert that. So you'll have to convert it to our format and then bring it in.
Okay.
Okay. All right. So now that we have the part imported, and you can see the unit says it's in millimeter units, the first step is we want to make sure the part is in the correct model units, and we also want to make sure the dimensions are correct. So we can go to analyze and check the part information. It gives you the length, width, and the height based on the current orientation. So the length is the distance along the X. So it says the total length is about 75 millimeters. The width is the distance on the y-axis is about 11.8, and then the height, which is the z-axis, is 74 millimeters. So do these numbers look correct for the length, width, and the height based on what we're looking at? Orientation? Okay, great. So the next step we want to do is we want to orient the part. Orienting meaning rotate the part so that it's placed correctly for milling. So based on the way the part is modeled, to me it looks like you want to mill it down, looking down from the side, right?
Yeah, that's right.
So which is basically the Y. So if you look at it from a isometric view or a perspective view, it looks like the part needs to be rotated. We can rotate it using the CAD transformation tools. We can rotate it about the X-axis by 90 degrees, which would lay it flat, so that the piece can be milled. Or you can use the tools in here by going into setup, and you can select orient the part, and you can select oriented, and I can choose the orientation to be this particular face where the y-axis is currently pointing. I can select that, and then I pick OK. It'll automatically reorient the part. Okay.
Okay.
That would be one of the ways to do it. Or you can use what is called the transformation tools, where we can use our graphical manipulator and you can define the orientation. So for example, if I need to flip it over, I can say flip this over by 180 degrees. It'll flip the part over. Okay. So there are different ways you can do it. You can use the CAD tools, or you can use the tools available in CAM. Now, once the part is all, you have it oriented, we can go through the process here. We can define the machine tool. This part can be programmed on a 3-axis setup. You leave it as 3-axis. If you plan to do it as index 4-axis, that's when you select 4-axis. If you just program it in one orientation, one direction, you leave it as 3-axis.
Okay.
The next step is basically you can choose the post processor. You can do it either at the start, or you can do it at the very end when you're ready to post process.
Okay.
Would you happen to know what the controller or the post processor you'd be looking at?
I've got a HeidenHain control.
A HeidenHain, okay.
It's a TNC 320. Okay. It's pretty equal to I think. Let's take the TNC 620. Should be just fine for it.
Okay. Yeah, and the post processor can be edited and customized. You can click edit, and we have a built-in post generator which would allow us to tweak and customize the post processors in here. So that's how we develop new post processors, by obtaining the documentation sample code, and we will be able to adapt and make those changes to the post processor.
Okay, is the post processor generating ISO code, or is it the HeidenHain language?
Right now, this one, what we see here, the TNC 620, looks like it's the HeidenHain language, but we do have an ISO code as well for the post processor. So here, if you take a look at, these are all HeidenHain formats. The ISO, we have an ISO, generic ISO format in here, which can output in G0 and G1 format, as you can see. So it can be set up for either one. We can have different posts, one for each. So this particular one uses the ISO for the HeidenHain's format, the one that you're looking at.
Perfect. And then I read that your new version is supporting some Python code in your post processor. Can you tell me what it can do for me?
Absolutely. So you can use our legacy post format, which has been around with all of our products since our initial release, or we can use a programmable post using a script editor like a Python, and you can select the post processor in here. We can point it to the folder where these posts are located, and you can use a Python scripting language to basically go ahead and script your post. So you can look at there's a help documentation in here, which basically talks about how you can use the Python language to write a post. And there's also a sample script in here, which basically shows you how to develop a post processor for each events and how the events are handled.
Okay.
So if in the help file, there's a documentation for it. So you can either use our legacy post or you can write your own post using the Python language.
Perfect.
Okay, so we have the machine defined, we have the post. The next step is to build our stock material, which is the blank that you're going to be starting with. So with the standard and expert configurations, you'll have access to box, part box cylinder, and part cylinder stocks. So as you create the stock, the system automatically computes the minimum stock required based on the bounding box. So it gives you the length, which is the distance on the X. Now you can see it's about 75 millimeters, the width is 74, and the height is 11.8. And you can specify your own dimensions in here. If the stock you're going to be starting with is, let's say, 100 by 100 or 80 by 80, you can override these dimensions. Or if you feel that the stock just needs to be a couple of millimeters larger than the part itself, instead of defining as a box stock, we can do a part box stock where we can specify an offset in each axis. Each of the axes can specify an offset. I can say 2 millimeter larger in X, 2 millimeter in Y, and then in the Z axis, I can say Z positive only, maybe half a millimeter or 1 millimeter, right? So that'll do.
Is it possible to do C positive 1 millimeter and C negative like 10, for example?
Good question. The answer is yes and no. So right now, the Z positive and Z negative, they're both mapped to the same box in here. So if you want to have a Z positive of 1 and Z negative of 10, right? So what we can do here is we can actually draw a vertical line that is 9 millimeters from this here, and then extend it out. So that way you can get that 10 millimeter out there.
Okay.
Am I making sense? So for example, here I can go ahead and put a line. I can say curve modeling. I can draw a line, and then I'll pick the lowest point on the model. I could pick anywhere over here, right? And I can say at 0, 0, -9, right? So from this point, I can create a line that's 9 millimeters long, or I can move this to the origin and let me go back and do it. That would be easier. So let me put the stock part here, set to part, I would say lower Z southwest. I'm going to put the part to the origin right where it is, right? At this location right here. And I can basically draw a line in here. I can use the tools that are available in here, and I can put a line starting from 0, 0, 0. I can go wherever I am, any of the viewports. I can go in here, draw a line starting at 0, 0, 0. So I can basically start the line at 0, 0, 0. That's where it's starting, and then I can say 0, 0, -9. So I'm just putting in a vertical line just to drop it right there. Right now, when I go to stock and do a part box stock, now I can say both positive and negative Z, 1 millimeter. So 1 millimeter from the top, and then it'll go 9 plus 1 millimeter because it's also taking the line into account here. So now you get but we do, we'll have an enhancement request for being able to set different stock heights in the Z for positive and negative. But this is the way you can easily accomplish it currently, by basically just for making an extrusion or some sort of a geometry in here and use that. Okay. Now we have the stock defined, the stock is aligned. The next step is to set the 0. So you can either move the part and the stock to the origin, or you can insert what is called a work 0, and you can say put the 0 to the top, highest Z northwest or highest Z southwest. You can choose where you want to put the XYZ origin or your work 0. You can choose a location. So that's my location of the work 0. The world origin is still right in here. Okay. In the next step, we would like to start milling, and the first thing I want to do is like a facing operation to face it down to the thickness of the part, right? So we have an operation called a new operation in 2021. It's called face top. So face top operation will allow you to face it, and you can choose like a face mill. to face it. And if you have a tool that's wide enough to just do one pass across, you can do a single cut, or you could use basically, you could do, multiple cuts. You can do a step over instead of doing a, you can say specify a step over in here. You can also specify an offset in the length and the width. I can say go 20 millimeters in length and 20 millimeters in the width offset. And you can choose a cutting direction, whether you want to go climb, conventional, or mixed cut. Specify your tolerance. Stock is the XY offset, and then in the cut levels, it automatically knows the top and the bottom Z, and it'll just do it in one level. So it's giving you one Z cut, and you can basically go ahead and base it off.
Perfect.
And you can apply different colors in simulation as you can see it. You can always go back and make changes in here, how far you're extending. You can just say the length offset is the distance along the X, the width offset is distance on the Y. You can specify this here and then go back and regenerate it. You can also change your step overs. You can always edit the operation out. And you can apply different colors based on the tool, and then the simulation will be able to show those colors.
Okay.
All right, so now we have it faced. The next step is we want to go ahead and program the toolpath. So you probably want to pocket these areas out, right?
Yeah.
Remove material. Now there's multiple different ways you can do it. Since these are at different elevations, you could program them using like 2.5D milling, or you could use a 3-axis milling strategy, depending on how you want to program this. You want to keep it, you want to have more control, you want to do it like step by step, you can do 2.5D operations. So for this open pocket, we could use 2-axis facing. The cutter will start from the outside and work its way in. So if we choose 2-axis and facing, and I can go ahead and select these edges around the model. So you can basically select these face edges on the part that you have.
Okay.
And I can specify a cutter. I could say I want to go with a 12 millimeter cutter, or I can go with a smaller tool, right, or a larger tool, depending on how wide this is. Set your feed speed, set your clearance. And in the cutting parameters, you can specify if you want to leave any side stock, like a wall stock, so you can go back and do a finish cut. I can say leave a 0.5 millimeter side stock. You can choose your step overs. In the cut levels, you can also pick the depth. I can just say start it here, and then I can pick any point on the floor. I don't have to pick it exactly on the same edge. I can pick anywhere over there. And now I can specify I want to split this into 2 passes. And once you have this specified, you can also control your entry and exit. You can specify arc fitting tolerances and then generate. So this will create a facing operation for programming open pockets.
Okay. Would it be possible to mill this adaptive?
Absolutely, we could do that. So let's go ahead and take a look at this one here, and then I'll cancel this operation and we'll view the adaptive. We'll take a look at that. So that's using a facing operation. Now, the adaptive machining is a new operation that we have in version 21. It's an additional module. It's an add-on module that can be added to any of our product configurations, starting with standard. So adaptive roughing, you can basically either select surfaces, or it will basically look at the entire model. We can specify the tool that we'd like to use for it. I could use a 1/2 inch or 3/4 inch. Have it in different sizes in here, and you can define your own parameters. You can set your tolerances, the stock to leave. You can specify the cut pattern, and you can also control the cut levels in here. I could specify those, and then in entry and exit can also be specified. And now when you pick generate, the adaptive roughing looks at your stock, it looks at the part and creates those toolpaths for you right there. So you can specify, you can also specify the cut level start and bottom. So if you go to cut levels, I can pick the start of cut. I can say the top is I already have milled it down to this level, and then the bottom I can pick is I only want to go down to this level right here, right? Or I can go all the way down to this point right here. I can say the bottom is going to be right here. And then I can specify in how many number of levels I want to cut it. I can say 2 cuts, for example. And
would it be possible to cut it in once and just do additional cuts if they are flats?
Yeah, we can specify number of levels as 1 and then generate it. So that'll go ahead and program the adaptive. So over here, I would have to break it up into more levels to be able to cut this one. So let me put in cut levels as, I can control the cut levels in here. So you can specify the number of levels and then generate the path. So that's basically doing adaptive roughing over on the front section right there. So you can see the cutter is starting from the outside and it's working its way in. So this is a module that we currently have as an add-on, which can be added to the standard, expert, pro, and premium configuration as an add-on. You can add on to the, mill module configuration. Now, if I go back in here and select this, I can also reduce my step down in here. I can specify the step down distance. I can set it to like a level. Maybe I can say 5 or 6, or we can put in the step down control and also generate the toolpath. So this will create multiple levels in the adaptive roughing pass, right?
Okay. And what if I just want to mill the open pocket at the end of the workpiece?
Just this open pocket over here?
Yeah,
okay.
Yeah.
All right. Let me go back in here. Let's go ahead and let me go back and make a little change in here, and let's go back and do that. So let's go ahead and I'm going to cut this operation out, and then I'm going to say align set world set to start. Okay, so I'll put the origin right over here, and let's go back and generate the adaptive roughing. Okay, so now you can see that it did basically program every feature on the part right there.
Yeah.
Right. So in the cut parameters, I can also control how far down you want to go, and down in the Z, I can say bottom is I only want to go down up to this point. I don't want to go past that one. And also clean up the flat. It'll clean up the flat faces, and we can always adjust the step overs. Okay. So I will go back and just remove this cut level containment here, the clear flat. Yeah, we should be able to get this toolpath. So it's doing both. Let's run a simulation here. Now, this is the adaptive roughing. We also have what is called the high-speed machining toolpath method, which is available in 2 axes like pocketing. We have a high-speed cut pattern in here. We can use a high-speed cut pattern, or we could even use like a slot milling operation in here if you can program this as a slot. So the high-speed you need to have a closed pocket, so which means you need to extend this out and make it a closed pocket, and then you can use like a high-speed cut pattern. The adaptive milling, adaptive roughing is a new toolpath method which is offered in our 2021 version, and it's an add-on that you can add on to it. Okay.
Okay.
Any other questions?
Not so far. One thing probably, I'm using 3D mouse from 3D Connection.
Mm-hmm.
And I figured out that sometimes I got problems to rotate the part.
Yeah, you need to make sure you're in the quad viewport to rotate it. So when I go to the quad viewport, you can see I'm able to rotate it.
Yeah, right. And sometimes I don't know why it's losing the green point in the middle, and then you can't rotate it anymore.
Okay. So the easiest way for you to do it is, probably it's thinking it's not in a rotation mode, it's in a planar view. So if you rotate this manually, it goes away. So you see that it goes away now.
Ah, okay. Okay,
So,
that could be the reason.
yeah, so you just have to go back and go back to the, like, if you go back and reset the view to a perspective view right here, now you should be able to rotate it again.
Ah, okay, perfect.
So just click on the view, it'll reset it back to a perspective view, and then or isometric view, and you should be able to rotate it. So you still get the controls back for rotation.
Okay, perfect.
Okay.
Okay.
Right.
Yeah.
And then you can basically program these holes using hole pocketing or drilling. So there's different operations that you can apply for programming the holes.
Okay. Don't think this would be that difficult. Yeah, one more question. Is it possible to use chamfering tools which are made for chamfering both sides, so top and bottom?
Sure, you can chamfer them using a chamfer tool. So you go into 2-axis and you pick chamfering, and you can specify the region is basically the edge. So in this particular case, you have already modeled the chamfer, right? So you'll have to pick this edge, the bottom edge where the chamfer ends, as a control geometry. So I can say select curve edge region. I'm going to pick this edge. I could also pick this one, these two edges in here. I can pick them for the chamfering, and then you can grab the tool that's most appropriate for the chamfer, right? So if I measure this, analyze distance, I can measure the point here and here. It gives me the delta Z. So if you delta Z is 6 millimeters, right? So the chamfer width is 6 millimeters. So as long as your tool is, you can specify the parameters in here to the geometry at the bottom. Chamfer width is 6 millimeters. You can also account for a tooltip clearance, maybe 0.5 millimeter. And then the maximum depth per cut I can put in as, let's say, 2 millimeter per pass, or you want to just take it all in one cut, I can just put in at least 6, or I can say 7, and I can choose which side to place the cutter, to the right side or to the left side, right? And you can specify the entry and exit parameters. You can, basically have a tangent, extend it out by a certain distance in here. I can specify the same, and then generate it. So that will give us a chamfer cut, and you can see that it cuts the chamfer. We just did it in one pass, one go. If you want to do multiple steps, we can do multiple also, or I can extend the entry and exit so it's long enough, or you can just draw one straight line. If you don't want it to have a lift up in between, here's the nice part. You can go into our curve modeling, and I can select, I want to start over here, draw a line, and go up to this endpoint. And now I can pick this curve as my drive geometry. So it'll be just one curve. The cutter will stay as it's cutting. And I can slow it down during the simulation also. So there's no retract, and if you want to do it in multiple steps, we can do multiple steps also.
Yeah, but I thought about the double-sided chamfering tools. You know them? Normally they got inserts, and you can chamfer from the top and from the bottom.
Okay, so what you would have to do is model them as a user-defined tool, and then program it as either as a profiling or an engraving. So you will have to model 1/2 of the tool profile, and then you can define it as a user-defined tool, not as a chamfering tool. You can go and define user-defined. So if you look at the help section here, we talk about how we can create user-defined tools. Let's go in here. There's a topic for user-defined tools, and you can basically draw the tip of the tool at the origin. You model 1/2 of the profile, and then you select it. And when we select it, we'll revolve it to create a tool, and then you can program it using 2-axis profiling or 2-axis engraving to cut both from one side. So you just have to model the cutter.
Perfect. Okay, so I think I don't have any more questions.
Okay.
That's all I wanted to know.
And then the final thing is post-processing. So you can select the setup or the operation, right-click and post. It'll generate your output file. If you want to do the output as .h, we can output as .h file extension, or you can do NC or ISO, depending on